Welcome to In 5 Minutes. We are now going to discuss modified block diagram of filter method. Please remember that our aim is to generate single sideband suppressed carrier, which can only be done from double sideband suppressed carrier. The problem that we faced earlier is that we have to design the filter at high frequencies with very large quality factor. We will still design filter with large quality factor, but the design of the filter will be done at low frequency. That is because we first generate double sideband suppressed carrier at low frequency. We separate one of the two sidebands. We only allow the second sideband to remain in the signal. And because the signal was generated at low carrier frequency, we perform something called as frequency translation to higher frequency, or something called as frequency up conversion, and we convert this whole signal to some high frequency. We transfer the whole signal to the final carrier frequency. So before we transmit the single sideband signal, it will be available at the desired high carrier frequency. So this very simple and smart modification in the design is done so that we don't have to design the filter to operate at high carrier frequency. I repeat, this new modification, you design the double sideband suppressed carrier signal at low frequency first. You remove one of the two sidebands at low frequency only, and then you perform frequency up conversion. You send the remaining sideband which is present at low carrier frequency, you send it to final high carrier frequency and then transmit it. So let's see how would the block diagram look like. You can see we have a crystal oscillator. Crystal oscillator will generate a very stable carrier signal. So output of the crystal oscillator will be nothing but the carrier signal. We use crystal oscillator simply to get highly stable frequency coming out. The output of the crystal oscillator, which is nothing but a single frequency sinusoidal signal in the form of carrier signal, is given to a balanced modulator through a buffer block which will provide the impedance matching. Balanced modulator is the same balanced modulator that we have discussed before, which will basically multiply the two signals. The second signal is nothing but my modulating signal. You can see it is coming from some modulating signal source. AF here stands for audio frequencies. Once again, it is first amplified to the desired levels and then given to the balance modulator. The output of the balance modulator will be obviously nothing but the double sideband suppressed carrier. How this whole thing will be different from the previously discussed block diagram, that the carrier that we have will not have the final frequency of FC. It will have some low frequency, let's say F1. Alright, so the double sideband suppressed carrier which is generated at this particular point will have the frequencies present from F1 minus FM to F1 plus FM. Earlier it used to be FC minus FM to FC plus FM, which is not the case now because the carrier is not generated at the frequency of FC. It is present at frequency F1, which is less compared to FC. Okay, now we have got double sideband signal. We'll have to remove one of the two sidebands, for which we use sideband suppression filter. Now, let us first focus on the upper branch of the transmitter. Let us say this is the sideband suppression filter which will suppress lower sideband. For example, in that case, output of this filter will be nothing but the upper sideband. So let's say if I get upper sideband at the output of the first filter, the frequency range of the upper sideband will be from F1 to F1 plus FM. Alright, because the other side from F1 to F1 minus FM, which is my lower sideband, is suppressed by the filter. You can see there is only one sideband which is available at the output of the filter. Now, we can't transmit this signal directly through the antenna because the problem is that the signal is generated at low carrier frequency of F1. It is not present around the final carrier frequency of FC. And why this was done? So that the filter that we are using here is very simple to design. If you now observe, the filter has to remove the lower sideband which is present around frequency f1. So let me quickly draw the frequency spectrum.